All right, guys, so this is a video about pressure. Thanks for checking out my channel. If you haven't, subscribe or check out my other videos. I'm trying to get the channel monetized. I have a bunch of videos about instrumentation, and most of the videos are geared towards new people. So this video I'm going to discuss pressure sensors, pressure switches, atmospheric versus gauge pressure, different units, and then talk about the column of liquid and how that works with pressure. Something I've noticed is a lot of people are lacking in understanding of this area, and like at different jobs I've had, and understanding how pressure works. It really has to do with almost every industrial process you're going to have. You have to understand how pressure works to really be a good technician. So if you feel like you don't really get it, or if you feel like you're starting a new job and you're just worried that you're not as sharp as you need to be on some topics, check out my video. This video is basically just going to be off the top of my head. If anyone notices any problems or anything I say wrong, please let me know in the comments. I don't want to steer anyone wrong. But without further ado, here we go. So there's two main types of pressure. You have atmospheric pressure and gauge pressure. So you might have a sensor that reads in PSI-G, which is PSI gauge, or PSI-A, which is PSI absolute. Generally, most things are going to be in gauge pressure. So if it just says PSI, it's most likely reading gauge pressure. And all that gauge pressure means is you're taking a pressure measurement and you're ignoring the pressure of the atmosphere around you. So we're all sitting, down on the earth, and above us, there's a bunch of air, and that air has weight. So all that air, that column of air that's sitting on top of us, there's actually weight to it, and because of gravity's pulling it down, and it's actually pushing on us all the time. And typically at ground level, you're going to have about 14.3 pounds of atmospheric pressure. So if I was holding a pressure sensor right now and it was a PSI-G sensor and I was just holding it up in the air, I would read 0 PSI. If it was a PSI-A sensor, an absolute pressure sensor, which is measuring, which does not include atmospheric pressure, it's reading that on top of whatever else pressure you have. If I had a PSI-A sensor, it would read 14.3 PSI right now. Okay, so units of pressure, you have PSI, which is pounds per square inch. So think about it this way. If you have 5 PSI, and again, we're going to talk about, from here on out, I'm just going to talk about gauge pressure. Forget about atmospheric pressure. At ground level, the pressure is 0. So 5 PSI is like having a 5-pound weight sitting on a 1 by 1 square inch area. It's the weight or the force per area. So you have pounds per square inch, you have pounds per square foot. Other types of pressure readings are inches of water and inches of mercury. Those are going to be your main ones that you're going to see in industrial settings. And inches of water and inches of mercury are kind of smaller measurements, used for small pressures. Pascals, kPa, kilopascals, that's another pressure unit that's pretty common. So you might notice inches of water sounds a lot different than pounds per square inch. Pounds per square inch, it's totally intuitive. This is how many pounds for every square inch. That makes sense. Inches of water, you might be thinking, that's strange. Well, think about it. When you take a pressure measurement and you're reading the pressure of a column of liquid, it doesn't matter how much volume you have. It just matters the height of the liquid and the density of the liquid. So think about swimming in a pool. You swim down to the bottom of the pool, and your ears pop. 10 feet down, your ears pop. Now think about this. When you swim down 10 feet in the ocean, does it feel like more or less, or does it feel the same? Now the ocean might have a little bit of a different density because of the liquid, but whether you're in a pool or the ocean, or just a tube of water, whatever height you're at, it's going to have the same pressure in each of those situations. So you can look at any column of liquid, and if you know the density, that will tell you the pressure at that level, at that depth. And you know, this comes up a lot in factories and industrial processes. You got to understand that concept, because you know, you're looking at industrial processes, and that stuff matters. Like, let's say you have a pump and you have to pump water out, and the water comes out of a pump and it goes up a 20-foot vertical column, and then it goes out to wherever it's going. Well, you're going to have a much different pressure at the output of that pump than at the top of the column. And if the pressure that that pump is outputting isn't enough to overcome that column, then your water's not going anywhere. If that head pressure is not, you know, if it can't overcome the head pressure of that column, then your process isn't going to work. So, you know, when you're troubleshooting processes, this stuff comes up all the time. So if you know the density of a liquid, that you can measure the depth using pressure. And a lot of times that comes up. You can use a pressure sensor for depth measurement. You can obviously also use a pressure sensor on a liquid system that is pressurized and flowing. But when that happens, you got to take into account the head pressure. So say you're, you know, have a flowing liquid, you know, whatever level the highest point in that liquid is, that head pressure, that pressure from that depth is going to be added on to whatever your measurement is, even if the process is flowing. And so if you have a pump pumping stuff out, you're going to have to, you know, take into account that you have that head pressure from that column of liquid plus whatever extra pressure that pump is creating. And when you're looking at your pressure measurement on a flowing liquid system, there's a couple things that can go wrong. For one, if you have cavitation or any bubbles in your process, you're going to notice that those pressure readings are going to jump all over the place. So if you ever are taking a pressure measurement on a flowing system of liquid and you can't get the readings to stabilize, for me, that's the first place I look. I look for leaks. I look at the inlet of the pump and make sure that, you know, whatever's going into it is all liquid, and just look around for leaks. That'll make you jump around a little bit. If that doesn't work, then you got to look at your circuit. You look for ground loops. You have a 4 to 20 milliamp signal. There's going to be shielded wire to absorb the electrical noise, and you just want to hook that wire up to one ground, and that should all be on your schematics. So anyways, that's a little bit about pressure. There's pressure sensors and there's pressure switches. Pressure switches are going to just be a 1 or a 0, a yes or a no. Let's say you can set a pressure switch for, let's say, 10 feet of water. And that's good for an application where you want things to turn on and off automatically as they fill up or drain down. So you would calibrate that 10 feet of water depth on your pressure switch, and maybe there's no voltage passing through that switch. Again, it's either on or it's off. Then once, you know, your process fills up to a certain level, that pressure switch is going to activate and it's going to close a set of contacts. And that, you know, that's a simple circuit. You can just run your power to turn on your pump through that set of contacts as long as it can handle the load, and that can turn on your process. There's a lot you can do with pressure switches. Pressure switches are very simple, they're very robust, they're usually mostly mechanical, and you can usually tune them to whatever level you want. Where pressure sensors are typically, you know, they're analog sensors. They can tell you, are we at 0% pressure? Are we at 100%? And you can buy different sensors for different applications. Obviously, you got to pay attention to your range. So if your process goes up to 100 psi, maybe you want a 0 to 100 psi range on your sensor. So let's say you have a 4 to 20 milliamp output sensor with a range of 0 to 100 psi. If you have 0 psi on your process, you're going to send out 4 milliamps. if you have 100 psi on your process, you're going to send out 20 milliamps, and then you can have 0 to 100%. You just got to do the math anywhere in between. So that's kind of how pressure sensors work. Okay, so once you have your pressure sensor set up, you got to calibrate it, and typically all you do is you remove your sensor from whatever industrial process you have it attached to, and you hook up a standard, and you can measure the output based on the real standardized, super calibrated standard you have. So say I have a fluke pump, and I set the fluke to you set the fluke to 0 psi, then you make sure that you have 0 psi output. Then you set the fluke to 100 psi, you make sure that you have the 20 milliamp output, and you check your transmitter, you check your readings, you can calibrate different parts of the system. Maybe you're just doing the loop check to verify the 4 to 20 milliamps coming out based off those standardized pressures that you have attached to your sensor. Maybe you're checking the whole thing, the whole process. So you apply the real pressure, and then you go back to the control room and you look on the SCADA screen, and you can do your calibration that way. And that's all going to be set up when you show up. You just got to kind of follow the procedure and pay attention to detail. And a lot of pressure sensors have it where you can there's a little potentiometer, like a tiny little screw, where you can just tweak it a little bit and it will go to 0, and then a span screw where you can just tweak it to get it, at your full range to get that 20 milliamp output. Should be noted, I keep talking about 4 to 20 milliamp output. There's other types of outputs. Another pretty common one is 0 to 10 volt outputs. The problem with 0 to, a voltage output rather than a milliamp output is a voltage output. That voltage will actually drop over longer distances through the wire. The resistance in the wire will actually consume the voltage. So if you have to, install a pressure sensor, and wherever that input is going, if it's really far away and you got to run a lot of wire, you might have some voltage drop. But if you run a milliamp signal, that the current in that entire loop is going to be the same throughout. So you have voltage drop over long distances. Just keep that in mind. Voltages aren't as common in industrial application as far as measurement, but they're definitely out there. Let's see here. So just to recap, you can measure pressures on a pressurized gas. You can measure pressures on a pressurized liquid. You can measure pressures on just a column of liquid to tell you how tall it is. And of course you can measure pressure on flowing liquid. And if you're having unstable readings, if it's a flowing liquid, look for bubbles in the process. If it's not flowing, you want to look at your grounding, make sure there's no ground loop, make sure that you have your shield installed properly with one ground point. So those are some pro tips for you. I know this video is a little bit more technical than most of them, and I know it's kind of off the top of my head. That's just, I find that I do it better if I don't really plan it out. My videos tend to work better if I just talk. So anyways, I really appreciate you guys tuning in. I don't think I have any more on this topic, so I will catch you next time.